Assalamu alaikum. Welcome back to the Telikilaas of Grade 10 Mathematics.
I am Shudat Miss from Huravi School. Hope all of you are doing great and are ready for today's lesson.
Let's recall a few important points you have studied before. Let's write what you know and what you want to know about probability in the SKW chart. Okay, shall we go through a few points together since it is required for further concepts? It is a measure of how likely an event is going to happen. Probability is measured on a scale from 0 to 1. And probability of an event does not happen can be calculated by subtracting probability of an event happening from 1. To calculate the probability of a single event, we can use the formula number of desired outcomes divided by total number of possible outcomes. Okay students, let's use the formula to calculate the probability of a single event given in the question. Can you try on your own? What is the probability of getting a 6 when you roll a die? First of all, find out the possible outcomes. So the number of possible outcomes on a die is 6, right? Because it's 6 face. And getting a 6 is just 1, right? So the number of desired outcome is 1 and the number of possible outcome is 6. When you put these values in the formula, we will get 1 over 6. Did you get the same answer? Well done.
Students, I have a set of cards here, okay? A total of 7 cards. 1, 2, 3, 4, 5, 6 and 7. So I have a total of 7 cards here, okay? What is the probability of getting a green card from this set, okay? So there are a total of 4 green cards, right? So it will be 4 out of the 7, right? 4 is the desired outcome because I want a green, and the total number is of possible outcomes is 7, isn't it? Now I'm going to take the green card and I'm going to remove it, okay? Again, if I want to select a green card, will the probability be same? Do you think it will be the same? What about the total number of cards here? Okay, here's one more question. I'm going to put back the card, okay? Now we have 7 cards here, okay? And I also have a coin here, okay? I'm going to flip the coin as well as I'm going to select a card from this set. Both events together, okay? I have combined flipping the coin and selecting a card. Do you think if I get a head or tail in the when I flip the coin will have any effect on the selection of a card here? Do you think selecting the green card will do any difference in flipping the coin?
Today we will be learning about probability of independent events and dependent events. You will be successful if you can determine whether events are independent or dependent and also calculate the probability of independent and dependent events. The events of probability can be divided into mutually exclusive events, independent events and dependent events. You have already learned about mutually exclusive events. Those are the events which cannot occur together. For example, when you roll a die, it is impossible for the score you get to be both even and odd at the same time, isn't it? To calculate the probability of mutually exclusive events, we find the sum of both the probabilities. We call it the O rule. In today's lesson, we will be looking into dependent and independent events. What are independent events? Two events are said to be independent if the occurrence of one does not affect the occurrence of the other. That means the occurrence of one event does not affect the likelihood that the other event will occur. For example, when we flip a coin together with a die, okay? You roll a die and flip a coin, both events are happening together. Whether you get a head or a tail when you flip the coin will not make any difference on the score you get when you roll the die. So the result of flipping the coin will not make any difference on rolling the die because both of the events are independent. How can we calculate the probability of independent events? When two events are occurring, since they are combined events, the first event is referred to as event A and the second event is event B. By combining both the probabilities A and B, we have probability of A and B is equal to probability of A, which is the first event, multiplied by the second event. In other words, to find the combined probability of independent events, what we are doing is we are finding probability of each event separately and calculate the product of it. So, the probability of two independent events A and B is the probability of A times the probability of B, which is the second event. So, the first event times the second event. Here is an example. If you roll a six-sided die and flip a coin, what is the probability of rolling a 5 and getting a head? So the important information here is the die is six-sided and we should get a 5 and also get a head, right? So let's have a look at the first event. The first event is rolling a 5. What are the possible outcomes? What are the possibilities when we roll a die? When we roll a die, we have 6 possibilities, right? So we use the single event probability formula to write the fraction for this particular event, the first event, which is rolling a 5. Since we can get a 5 only once, we have 1 over 6. Let's look at the second event, probability of getting a head, right? So you can either get a head or a tail. There are no other choices, right? So getting a head is 1 by 2. So now we have probability of each event separately. The first event is 1 over 6. Second event is 1 over 2. We will put it together now. Combine both the probabilities and find the product of both the probabilities. When we combine it, we have 1 by 6 times 1 by 2. And the answer is 1 over 12. So the combined probability of A and B is equal to, that is, rolling a 5 and getting a head is equal to 1 by 12. Remember, when you write your answer as a fraction, you should always write it in the simplest form. Here is one more example. You have 3 marbles in a bag. There are 2 green marbles, 1 purple marble. You randomly draw a marble from the bag, then put the marble back in the bag and draw a second marble. What is the probability of getting a green marble both times? So the important information in this question is highlighted with different colors. As you can see, the marble you take is put back, right? So the total number of marbles in the bag will always be the same, isn't it? Let's see how we can do the question. First of all, let's write the formula, the rule, and also write it in terms of what is given in the question. So probability of getting a green and a green, both events combined together, is probability of green times again the probability of green, because the same event is happening twice, right? So let's calculate the probability of single event, since the single event is the same thing happening to for the second event also, we are going to find it once. So the number of desired outcomes divided by the total number of possible outcomes, the same formula we use for single event we are going to use, okay? So we have a total of 3 marbles in the bag, you can see in the question, as well as you can see in the picture, right? How many green marbles? 2, right? Okay, so when we write the fraction, it will be 2 by 3. Now we will put this in the formula right over here, okay? So when we substitute 2 over 3 here in the formula, the combined probability of green and a green will be equal to 4 over 9. Next, we'll be looking at the dependent events. 2 events are said to be dependent if the occurrence of the first event affects the occurrence of the other. So, the likelihood of the second event is affected by the first event. For example, a bag contains 2 blue and 3 red marbles. What are the chances of getting 2 blue marbles without replacement? You can see we have a different phrase here, without replacement, isn't it? So these words tells us that the 2 events will be different somehow. Let's see how it will be different. We will use the single probability formula to find out the probability of the first event, that is getting the first blue marble, which is 2 out of 5 marbles. Now since we have taken one, the final for the second event, the number of marbles in the bag will be different because we are not putting what we took back in the bag. So the next time getting a blue marble will be 1 in 4. That means we got 1 by 4 for the second event. Let's see how we can combine this and calculate the probability of dependent events. Since we have 2 events occurring, we have the first event as A and the second event as B. When we combine both events together, we have probability of A and B, or probability of both events is the product of the first event and the second event together. So that is probability of the first event multiplied by the probability of the second event, that is B after A, meaning probability of second event after the first event occurs. Students, as you can see, there is a condition introduced here, isn't it? Here is a condition introduced here. Somehow the first event will have a difference, or will make a difference on the probability of the second event. Okay, so you will study conditional probability in detail in a later lesson. In this example, here is a box with 3 blue balls and 7 green balls. What is the probability of getting a green ball and then a blue ball without replacement? So we have to calculate probability of both the events separately. Okay, so let's do that. For the first event and for the second event, we calculate the probability separately using the single event formula. So for the first event, we have taken a green ball. So there are 7 green balls and out of total 10 balls. So we have the probability of getting a green as 7 by 10. For the second event, we have 3 blue balls, and also since the first one is taken and it's not replaced, we have a total of 9 balls left in the box now. Hence, the probability of the second event, that is getting a blue ball, will be 3 over 9. Simplified to 1 over 3. Now we got probability of each event separately. First event and second event as 7 by 10 and 1 by 3. Now let's combine these together. When we combine these together, we have to find the product of these two. So put it in the formula. We get probability of getting a green and getting a blue is 7 by 30 as we multiply 7 by 10 and 1 by 3. It's your turn. In a cookie jar, there are 3 red cookies, 1 green cookie and 2 blue cookies. Areen takes a cookie and eats it. After some time, her brother Aksam also takes a cookie. Calculate the probability of Areen selecting a red cookie and Aksam also selecting a red cookie. So for the both events, we need to have a red cookie. The difference here is the first one is taken by Areen and she eats it, and the second one is taken by Aksam. Okay, so both the probabilities will be different. Let's see how we can do this. First of all, find the probability of both events separately and substitute in the formula. Let's write what is given in the question in terms of probability. That is, probability of selecting a red and a red. The combined event is red and red. That means probability of the first red cookie, okay, times probability of selecting the red after the first red is taken. Okay, we have since we have 3 red cookies altogether, out of how many cookies? 6, right? So out of the 6 cookies, we have 3 red cookies. So the first fraction is 3 by 6. That is, selecting the first red is 3 by 6. For the second event, we have a red again, right? But since the first one is eaten, we have 2 red left now. Also, the total number of cookies also is different now, since we have actually taken one, right? Let's just omit one from here. Okay, so when we just omit one from there, you can see the total number is now different, right? We have 5 cookies in the jar. As a result, there are 2 red cookies and there's a total of 5 cookies left. When we find the product of both, we have 1 by 5 as the probability of both events combined together. Let's see if you can identify whether these events are independent or dependent. A. Flip heads on a coin and tails on another coin. B. Your teacher chooses one student to lead a group and then chooses another student to lead another group. So, why do you think one is independent and one is dependent? And which one do you think is dependent and independent? Okay, let's have a look. The first one is independent because 2 independent events are happening. None is having an effect on the other. Okay, while the other one is in the other question. In this situation, the teacher is choosing a student to lead the group. So now, once the teacher chooses the first student, the total number of students in the group will decrease, right? So the second student will be chosen from all the students left. So therefore, it is dependent. How can we identify if an event is dependent or independent? We can look for clues like without replacement, with replacement. So if the events are dependent, we will have without replacement. If the events are independent, we will have with replacement. Or look for the clues which will tell you that the chances of occurrence of the events are not affected, or the chances of occurrence of the events are affected by each other. Okay, so the probability of both events occurring is the product of the probabilities of events here in the case of independent events. In the case of dependent events, the difference here is the first event and the probability of the second event is multiplied. So here in the case of independent events, you can simply multiply both the events, the first event and second event, or the events separately. After finding the probability of the event separately, you can just multiply it here. While in dependent events, we need to multiply the first event and the probability of the second event followed. So, might not be the same for both the events. Okay. Here is an exam question. A box contains 3 red pencils, 2 blue pencils and 4 green pencils. Raj chooses 2 pencils at random without replacement. Calculate the probability that they are both red. So, we will have a look at the information given here first. Okay. Since we know we have the word without replacement here, right? So let's think about the type of the event that is given in the question. Without replacement we have, so that means it is dependent, right? The events are dependent. So we have to first identify whether the events are independent or dependent. So as step 1 we have done the first step. Now let's look at the information given in the question now. In the box we have a total of 9 pencils and you can see 3 red pencils. So at the first event we have probability of taking the first red will be 3 by 9 and that can be simplified to 1 by 3. Now Raj is going to choose one, okay, and it is not replaced. So we are going to remove it from the box. Now the remaining red is 2 and the total number of pencils now in the box after the first event is 8. So for the second event we have 2 by 8 simplified to 1 by 4. Let's go back to the question. A box contains 3 red pencils, right, and 2 blue pencils, 4 green pencils. So we have looked at this information. Now the first event, the first step also we have done. We have calculated the first probability also, the second event probability also. Let's put it here. The first event is now 1 by 3, second event probability is 1 by 4. As the final step we need to combine both, because this is combined probability. We are trying to find the probability of both red, right? So red and red. Let's put it together. Multiply both the fractions, okay? The probability of red and red is actually probability of the first red multiplied by red after the first dot. So as you can see here, I have taken the fractions here, right? 1 by 3 and 1 by 4 and then multiplied here, and then the answer is 1 by 12. B part, they are both the same color. Let's look at the choices we will have if they are both same color, okay? There are different choices we have, okay? The possibilities are different now. So we have a possibility of red and red, or we can even have blue and a blue, or we could even select a choice of green and green. So if Raj is choosing red and red, there is no chance that Raj can choose blue, right? Because it needs to be the same color. If it is green, no chance that it can be blue. So these 3 possible choices are mutually exclusive events now, okay? So we have combined dependent events as well as mutually exclusive events here. Let's see how we can do this question. So they are both the same color. The number of choices we have just looked at, okay? We know it is dependent, right? And we can find the events separately. R and R, that is red and red, blue and blue, or we can have green and green. Now let's write this in terms of probability, okay? That is combined events of red and red multiplied, okay? The product of blue and blue, the product of probability of green and green. Now when we calculate both the 3 events together, okay, separately we find the events. We have already done the red one in the A part, okay? So we'll use that answer for this question. For this part we will use the answer of A part, okay? Now look at this. There is the word or. In the beginning of the lesson I have told you about mutually exclusive events. We have already studied that. So this or in mutually exclusive events, or means we add, right? So we have and rule and or rule here, okay, combined together. So all the o is replaced by the plus sign here, the addition sign here, okay, and the and is replaced with the multiplication sign here. So the arrow shown here is to illustrate that. 1 by 12, and for the blue we have, since 1 is taken in the first event, a blue, we have 2 minus 1, which is 1, and the total number also decreases by 1. Same thing happens with the green. So we have how many green pencils altogether? We have 4 green pencils. So the first fraction will be 4 out of 9, and since we are taking 1 and not putting it back, it will be 3 by 8 for the second event. So multiply what is in the brackets and then add everything together to get the combined event answer, which is 5 by 18. Okay, let's go back again. In the first step, what we have done is we have identified the possible choices, the possible outcomes of mutually exclusive events. Also, we have identified whether the event is independent or dependent, and as a third step, we have found the probability of the first event and then the second event. Okay, and we have multiplied all together. We know that now independent events do not affect the likelihood of the other events. Also, we know that dependent events affect the likelihood of the other events. So, independent events do not affect the likelihood of the other events, while dependent events affect the likelihood of the other events. Okay. In addition to this, we know that in both cases, in independent or independent events also, since they are combined events of independent and dependent, we multiply the probability of all the events. Okay. So, in this we use N rule. So, also you know that in probability O rule means addition while N rule means multiplication. As a step 1, we have to identify whether the events are independent or dependent. When you do a question, okay, whenever you get a question, identify whether the events are independent or dependent, or you can even look for the choices like mutually exclusive events. Second step is find the probability of the first event and then the second event. Finally, combine all the probabilities together and find the product of both events. Okay. Now, what you need to do now is you need to go back to the KWA chart which I have given at the start of the lesson. Okay, at the beginning of the lesson, you need to fill the last column, that is the third column, and write down what you have understood from today's lesson, what you have learned. Next, do the exercise on page number 169, which is exercise 8.3. And that will be all for today. Thank you. Study smart and stay safe.